Okay, so I'm recording on kind of a weird, um, with kind of a weird software, so I won't be able to actually show you the program running because it will only record this tab um, of the Strings Lab and the Visual Studio software. It won't record anything else if I open something else on top of it. I'll have to find better recording software for the next one, but so yeah, so this is the StringsLabShiftCypher lab for lab 5 and 6. I would say that or for lab 1 part 5 and 6, I would say that they're pretty much combined. Once you complete lab 5, it's really easy to move on to lab 6, and they intertwine really easily. And so I didn't use the ASCII stuff because I got excited and I wrote kind of a pseudo algorithm before I even watched the screencast, because I had an idea of how I could do it with some of the stuff from the Pig Latin lab. So yeah, so let's start with the main. So it starts with the console write line. Please enter a word or phrase. It gets the input with the console read line and puts it under the string of input. Next, I have it declaring a random gen, new random, and then declaring R&D as the next number in it as between -10 and 11, so that way it's between -10 and 10. So yeah, so this part is for lab for this part 6, but for part 5 I had a console read line that asked for the shift, and it'd take it int parse the console read line for under shift number. But instead here it's putting shift number as R&D, and it prints it out just so that way I can see it when I'm testing it. Again, I won't be able to show you it in action because of the recording software I'm using, but yeah, so then after that it prints out it does the console write line, convert to cipher. It takes the input, which is the strings, and it takes the shift number as an integer, and then it console read lines, so that way the program just doesn't automatically end since I'm using Visual Studio. But yeah, that's all for main. Pretty much everything else is contained in this convert to cipher function. So that way if I wanted to convert multiple things to cipher, I could. So in the convert to cipher function, it takes the string input and or it takes a string and it declares it as input, and it takes an integer, declares it as shift number. I have it declaring a new phrase as nothing, as an empty string for later on. Then we get to kind of the bulk of it. So I have a for each loop that does char j in input. So for each character in the string input, it will run this. So then it checks if it's lowercase. If it's not, it will check if it's uppercase, and if it's none of those, it will, which means it's not a letter, it will go to this else block. So, so yeah, so if it's lowercase, it will create a new int called temp index, and will it will go to this function I wrote called get lower alphabet index, and what this does, I'll show you later on, is it gets the index of the letter. So if it's like a B, it will search through the whole alphabet, which I have contained in a string, and it will find the index. So it will end up returning index 1, I think, for B, since A is 0. And so I have that passing into it. I have an integer, so it will be input index of J, because J is a char, not a number I have to do the index of. I'm not sure if this is entirely necessary, but it's what I have. I had something even worse before this, but that's what I have now. So yeah, then it creates a new char called temp char, and this is just to store a value before we add it on to the it will be the new value we get after the cipher, after that specific character gets ciphered. So it returns the new lower alphabet. Again, that's another thing, another function I'll explain later on. It takes the temp index from here, and then it takes the shift number, and what it does is it, I'll show you. And the new phrase equals new phrase plus temp char, so it just adds on to the end of the new phrase, which is right here. And new phrase is what ends up getting returned from this. But if it's an uppercase, I have it running through get upper alphabet index, and this is just to, so I have two different alphabet functions. One's for lowercase, one's for uppercase. I could probably combine them into one, but then there'd be some other complications with the looping of like if it's Z going to A and stuff like that. And then it returns new upper alphabet. Again, it's pretty much the same thing, just for upper and lower. And then this else here, this is just for special characters like semicolons, spaces, pretty much anything that's not in the alphabet, numbers, stuff like that. So it creates new temp char J just to add it on, and temp char equals J. So it just essentially just adds it on as if nothing changed, because nothing should change on those. So that's the StringsLabShiftCypher convert to cipher function I have, and it returns the string of new phrase, and that's what it will end up getting printed out. But now we'll go over the get lower alphabet index. So it takes char C, which is the char that we start with. It searches the alphabet for C. Like let's say we pass in like let's use B again. So it will go under the B. It will find the B. It will be index 1, and so it will that char index is what index of the char C is. So if we had B, it'd be 1, and then it returns that char index. And then I have the same thing for the uppercase alphabet, except for it's just all uppercase here. And this is something we did in the Pig Latin one, where it would search through all the vowels, but I just extended it so it searches through the whole alphabet for the index. And then, so once it finds the index, it will pass it into the return new lower alphabet or upper alphabet if we're doing upper alphabet ones. And so with this one, it returns a char. It takes int t and int StringsLabShiftCypher. Int t is the value we got from this, and StringsLabShiftCypher is the one we got from in main. And so I have this while loop here just because when they were entering in variables, this is for lab 5, or part 5, I mean. When you enter in like the shift number and it was like 324 or something, it would crash because it would only worked if it repeated once. So it would work if you were shifting like 4, but it wouldn't work if you're shifting over 26 plus the number you start with, because it wouldn't it couldn't go over through a certain number twice. And so what this does is it adds the two together to see if it's over 26 and or under if we're doing negatives, and if it is over 26, then it will minus it by 26, just so that way when we're shifting it, it will reduce it down to a number. So the index of the letter plus the shift number will end up being between 0 and 26. And this isn't as much of a problem in part 6, because you were supposed to do a random number between -10 and 10. But when you ask the user to enter in any number for the shift, then you're going to have to deal with the really high or low ones. So that's what this does here. Yeah, it will either add 26 or minus 26 depending on if you're going down by a bunch or up by a bunch. And so after that, it will get the alphabet, and then it will have char y, and char y will be in the alphabet, it will be, it gets the alphabet string, and it gets char t, which is the index of it, plus it's not char, sorry, integer t plus the shift number to get the new index for this alphabet, and that's what char y is. It will be the new char that's in that index, and then it will return y. And same with the new upper alphabet, it does the same thing. I could probably put this specific part into the main function, but I didn't. And so yeah, that's all my program. I used to have a thing to where it would tell me if it is lower or upper, because I forgot that there's a pre-built-in function for that. But yeah, so that's my Lab 1, Part 5 and 6. So yeah, this was Isaac Walters. I don't think I stated that in intermediate C#. So yeah.